A reference point is a starting point from which other things can be located. This is done by using information given, such as directions, up, down, right, left, and measurement, so many rows, so many inches, so many centimeters. Reference points are used in graphs, maps, compositions, and drawings. An example, when you enter the mall and you look at the map on the wall, it shows you where you are in relation to everything else. From it, you know that to get to the store you want, you should go to your left to almost the end of the mall, past 3 stores, and around the right-hand side of the fountain. Another example would be if we had a picture, such as this little house, and we wanted to duplicate it or transfer it onto something else, or possibly shrink it or enlarge it. The first thing you have to do is put it on a field or a grid. Here you have the little house on a field of dots, which there are rows and there are columns. Using the reference point, any part of the house can be found to scale. To find its position, you need to count over rows and columns. For instance, to find the edge of the house, it's 1, 2, 3 columns over. If you wanted to find how far down it came, it would be 3 over and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 down. It's always good to try and go back to the reference point, 3, 10. A mistake that's made a lot is to try to use one piece of information and then just add on to it, and then add on to it, add on to it, and add on to it. For instance, this is 3, oh, this is 2 more, this is 4 more, this is 2 more, this is 6 more. The problem you have is, if anywhere along here in these judgments you make a mistake, everything else is wrong. So it's always good to go back to the reference point, find out how far something is over, how far it's up or down. That way you'll get it right. I'll quickly go through this so you can see what I'm talking about. The house has 2 basic shapes. There's a triangle for the roof, that's the large one, and the large box for the bottom. For the roof, we know it's over 20, and then it's up 5 in between 10 and 11. But notice it's halfway. This is a judgment call, but you know where this dot is, so then you could draw and find the slope of the roof. Over 3, down 10. Over 17, down 10, and connect these 2 for the bottom. Now for the door and the door handle. Now for the window, note that the cross member is not on a column or a row. And the chimney. Now going back to the reference point each time to find each corner and line may seem like a lot in this little simple house, but sometimes it becomes much more important. Perhaps you're blowing it up to a field that's much larger and it has different number of columns or rows. Or it's more complex, such as this one, which is put on a grid rather than dots. Now let's talk about reference grids. They can be very helpful when your design has curved shapes, such as a circle. In a grid, you can number the columns and rows. This helps you locate different areas of your design quickly. To locate where this circle is on the grid, you need to find where it crosses grid lines and passes through columns and rows. It could be a straight grid, such as this one, or you could distort the grid and therefore distort the circle by finding the same points on the distorted grid and then connecting them. Let me show you how that works. The first thing we have to do is notice some things about where the shape lines cross the grid. For instance, right here it crosses column 3, column 4, row 1. It's about 3/4 the way up. You can divide this and say, okay, there's about 3/4. That works. Okay, you've noticed that. Now if we come over here between 2 and 3 and 1, if this is halfway, it's below halfway, about 1/3 the way from the bottom up. Then here, same thing, almost, maybe a little more than 1/3. Okay, you know where that one's located. Here again, here's halfway, so it's about 3/4 the way across. And you do the same thing around any curved surface to find where they are. Then we'll connect them dot to dot to dot and get the new shape. Let's transfer into a different grid. Now here's the grid we're going to transfer the circle into. But as you can see, this grid's distorted. It's not a regular straight grid, so the circle is not going to be a circle when we get done. Let's start finding the points of intersection on this grid so then we can locate what the circle will now look like. First I number the columns and the rows. Now when we looked at the intersection that was between 3 and 4, we said it was about 3/4 the way up. Okay, we'll look at this line. It's halfway, so about 3/4. The next one over here we said was about 1/3. Okay, that means that's going to be right about there. The next one again, about 1/3. This one, almost 3/4. And we'll continue around the circle plotting them. There they are. Now we just go dot to dot to dot. But because this is a curved line, there shouldn't be any sharp corners. It should all flow. By using the grid, the circle is evenly distorted when it's transferred. Now let's look at some more complex compositions with curves. Here's a little cartoon face with lots of curves as well as straight edges that you might want to transfer to something else. Here's some helpful hints on how to do that. When we look at this, once again, we can locate where things cross between rows and columns. We also can subdivide certain rows and columns. For instance, if we cut this in half, we find that's the top of the head. We also find that if we cut this in half, the ear never gets out to there. That helps you locate it, besides knowing this and this. Also, if you cut this in half, it helps you locate the top and the bottom of the circle that's the eye. This would be especially helpful if you were distorting this face. Other things you'll want to look for is symmetry. It's the same on both sides. So when you have one side figured out, the other side should be the same, unless you have some complex distortion. Never be afraid to subdivide your grid even further when it'll help you locate things. Let me show you how those might be helpful if you're transferring to a distorted grid. Just a couple of them. We found in the top row here, halfway was the hair. Okay, here's a distorted grid. If we cut that top row in half, we know that the hair stops there. Remember we talked about how the ears didn't go out to halfway? Well, they're not going to go out to halfway. Now as you can see by this grid, this face is going to be much bigger at the bottom, smaller at the top, and also the rows get smaller, so it's going to be squished more the further you go up. Let's look at the eyes. We talked about that. Halfway, we're talking about the third row. So here's halfway. It goes about 3/4 the way up. So we're going to come over here, and it's about 3/4 the way up. And it comes about 1/4, a little more down here. But it does not fill the whole column. We measure that out that it's right about here. So just like when we did that circle, we know these eyes are no longer going to be round. They're going to be stretched into a new shape. The mouth was easy. We had the spots here. We can locate them where they are here, and we found that it was halfway across the bottom one in the middle, so this curve would be found. That's how you would apply those kinds of little tricks to help you transfer things. Another example of reference grids can be used to make block letters. This way you can transfer them, make them larger, make them smaller, and distort them for whatever your needs are.